some of the equations that we use, or I guess not some, the equation that we use, you probably have seen in physics, those of you who are physics people. All right? So when I say free fall motion, I'm talking about motion on Earth, where we have initial velocity either up or down. So I'm either throwing a ball straight up in the air and it comes down, or I'm throwing something straight into the ground. Okay. Now, when we talk about, our positive and negative velocity, yesterday we were talking about right and left. If we're talking about free fall motion, okay, then velocity, instead of left and right, we're going to think of as up and down. Okay. Is that okay? Okay. It's still linear motion, right? Up and down versus left and right, it's still going to be the same concept. Okay. Now, we are going to assume that the only force acting on the object is gravity. We're not going to worry about any wind resistance, okay? And the actual size of the object, we're also not going to worry about. We're going to treat everything as just a particle, okay? Now, the further you dive into physics, the more you can deal with wind resistance and how big the object is and so on and so forth. Okay, right now we're just going to work with the basics. Okay, so maybe you remember this equation. All of you have seen this equation because I think in even Algebra 2 you work with it. Okay, when you talk about quadratics. Okay, you need to write this down. All right. So this is our position function where we know initial position, initial velocity, and gravity. Now, gravity is going to depend on what unit of measurement we're using. We have on Earth 9.8 meters per second squared or 32 feet per second squared. It would be negative. That's why it is minus. Okay? Yes, the pull of gravity is negative, and that's just going to be reflected in the equation already.
So when we plug in 9.8 for G, don't plug in a negative 9.8.
Correct. Correct. So let's talk about what our velocity and acceleration equations would look like. Okay, so if this is our position equation, what would our velocity equation look like?
The derivative is, I don't know how to derive S sub O.
What is S?
Sub 0 initial.
Okay, so the initial position is going to be what kind of a value? A constant, right? So the derivative of a constant would be nothing. Okay? The derivative of a constant times t would just be
constant.
Yes.
Aha.
Minus
GT.
Okay.
Ah.
So notice how if time is 0, we're just left with initial velocity. Okay. And then our acceleration, what's the derivative of our velocity equation?
G.
Negative G.
Hey, look at that.
Gravity. Okay?
Weird how that worked out.
Acceleration is just the pull of gravity. Crazy. Okay? So, we're going to apply everything that we did yesterday to our free falling equations. Okay? Things may just get, our numbers may not be as awesome, as nice, as pretty. Okay? Alright, so Jake went outside and was actually able to throw a baseball up at a velocity of 100 feet per second. He was actually able to do that. How high will the ball go? Assume he's throwing from 5 feet off the ground. Okay, so he's not 5 feet tall. He's over 5 feet tall, but he's throwing from 5 feet. So, first of all, let's set up our equation before anything else. So what is our initial position? 5 feet. What is our initial velocity?
100 feet per second.
100 feet per second. And which gravity should we use?
Probably the 32 one.
So our position equation is going to be 5 plus 100t minus 16t squared. Because it's 1/2 g. Right? Okay. If I want to know how high the ball would go, what would be special about that point? The velocity would be 0, which means we need to find
Critical
the
point.
critical point. Okay? Wherever my ball goes from going up to down, our velocity is 0. Right? It has to stop and change direction. So, what we can do is we can find our velocity equation, which would be
100 minus 16t.
minus 32t.
Okay.
So, where the ball stops is where this is 0. What's our time?
132.
Okay, well, let's, I don't know what that means. How many seconds?
3.125.
Thank you. 3.125 seconds. That is not what I asked for, though, is it? How high will the ball go? So if this is the time that the ball stops and changes direction,
312 feet.
You need to plug it into the original.
we need to plug it into our position.
One
160 what?
1.25.
Feet. Make sure you give you that label. Does that seem like a lot of feet to throw a baseball in the air?
No.
No,
No?
not at all.
Just straight up though?
68 miles an hour.
Not at all.
Okay.
I mean, for a trained pitcher.
Straight up in the air? Like I feel like that would
See,
be.
people overestimate how large a foot is.
Yeah.
That's true.
Like you have to imagine the base paths are 90 feet. So that's like me being able to throw from first to second straight up.
Okay.
Like times,
Yeah.
like less than, so that'd be like me throwing from first to second and then adding another base onto that, which I can do very easily.
I
So
could
it's-
probably get a solid 25 feet.
Good for you. Good job. Okay. All right, next example. A calculus textbook somehow finds itself on the top of Papillion La Vista South High School. Hopefully in the dirt.
It falls.
Falls off the
What
building.
happened?
This
What?
is the best math.
Look, you were there at
Okay.
the scene of the crime. What happened? He fell off the building.
Okay. Imagine whatever scenario you would like. Okay.
Oh.
How fast is the book falling after 2 seconds? What do we need to find?
Well, we need to know how tall this high school building is. I don't know off the top of my head.
No, you don't.
We don't.
In this scenario, the building is forever falling. Yeah. As long as it doesn't hit the ground.
Can we define our original position as 0?
Yeah.
Yeah.
Okay. Because we don't know the height of the building, but if we're not asked for any other height, doesn't really matter. Okay. So let's define our position. Okay, so we're gonna say the top of the building is 0, so we don't have to mess with it. What's our initial velocity?
Also 0.
Also 0. So our position is just negative 1/2
gt squared.
9.8 t squared, right? Well, I guess I just picked 9.8. I guess nothing has been said about feet versus meters,
Well, it says
right?
seconds. Oh, that's still feet per second. Isn't it?
Yeah. Okay. We're going to do meters per second because last time we did feet per second. All right. So if I want to know how fast the book is falling, I probably want what equation?
Velocity.
The velocity. So our velocity is negative 9.8 t. All right. Now, our velocity after 2 seconds would be what? However, how fast is the book falling? So that's really looking for our speed, right? So we really want the absolute value. So 19.6 meters per second is how fast that book is falling.
Velocity. Absolute velocity. How fast.
Honestly, though, I have a feeling by 2 seconds it hit the ground and it's going 0 meters.
Have you seen the tallest part of the school? Pretty up. Pretty up.
Yeah, but it'd still be up in the ground.
Okay.
Underestimate how fast.
Yeah.
See,
Interesting.
when it asks, okay, how fast is the book falling, we know it is falling down, and so the direction wasn't a concern, and that's why we gave speed. Okay. All right. How far has it fallen in only half of a second? Okay, so what do we got to do here?
Looking for T in position.
Okay, so let's plug in a half for position. Our position was
1/2.
negative 1/2 9.8 t squared. So what is our position?
1.225.
Okay, so our book has fallen 1.225 meters. Right? Okay, let me make you think a little bit more. How long would it take for the book to fall 50 meters if there were 50 meters available?
You said the position equation equal to 15.
Okay, we want our position to be, we want it to be negative 50 because we're falling, right? So we want our position to be negative 50. Okay, so this means t squared would need to equal
Negative 25. 25 divided by 9.8. Right?
no 100 divided by 9.8.
10 point. That's what I meant. I didn't mean that.
10.2.
Wait, square root it. 3.19.
Okay. Now, this one was nice because we only had t squared. We didn't have the t, we didn't have an initial velocity, we didn't have an initial height. Now, in your homework problem, it is possible that you will be asked something like this in a problem where you did have initial height and initial velocity. In that case, how would you have to solve the problem? It is possible you will need a quadratic formula. Okay?
Like after algebra 2 is kind of gone for a little bit, and then slowly like it just pops up like every now and again. It rears its ugly